Hey everyone, welcome to part two of our series covering a remake of Donkey Kong using 3D models instead of 2D sprites, but otherwise it will function just like the original Donkey Kong with a fixed camera and all the similar functionality. So you probably noticed a few minor changes that I did in between videos because I don't want to waste your time. These barrels, I just took barrels from the asset area, dragged them drop here because in the original arcade game there was a 2x2 pile there. I just removed the script, the collider, and the rigid body. That way they're not interoperable. They're just there for a visual effect. Added a few more ladders. That's just a matter of drag and dropping the prefabs and added another beam. And now we've got a stand-in for Pauline. This is a Sobi-chan. This is a free-to-use asset. It's on the Unity store. When you go to the page for this asset, there'll be a button that says Add to my assets. You click on that, and then, as typical, you can then download from Window and then Package Manager. Once you download the folder, you can just drag and drop the model right into the scene, no coding or anything else involved. Okay, so the bulk of this is going to be discussing the character and the character controller. So just let's get right into that. So here's our character. So we're going to go into the prefab and we're going to point out a few things. So first of all, animator. So depending on what model you're using, you're going to have a variety of animations. Now this one by default is set to go to idle when the object is instantiated. Okay, yours don't know if it's going to do the same thing. Most pre-made ones that you're buying from the store probably will be set up to default to idle. If not, there's a way to code around that. So that already takes care of idle. So in case you're wondering, that's why. Second of all, we will use walk, but as you can see, they're not connected yet. There's no transition. That's because we're going to call it explicitly in the C# script. Two other things I want to point out. This does not have a climb animation, nor does it have a jump animation. So we can indeed make the character move vertically for a jump and move vertically to climb up a ladder. They just won't have a unique animation for it. And again, I can show you the coding that if you do have an animation attached to it, how you can call it. It's pretty simple. Calling one animation is really no different than calling another. So once you see the coding, you'll know what to do. But yeah, it's going to look a little bit silly because he's just going to ascend a ladder without a climb animation. I want to call out that in the right hand there is a weapon. However, what I've done is I've disabled the mesh renderer. That way you can't see it. So it doesn't look like they have a weapon. So we're going to kind of trick the player. So what happens is he technically always has the weapon. He just can't use it. So what's going to happen is when he grabs the weapon from near the top of the screen, that object gets destroyed, and then this object just gets enabled. So a little trickery, but it works. I didn't call it out, but if you go back to Animator, there are some attack animations. And so that attack animation would then become accessible when he grabs the axe. We probably won't do that in this video. I think the coding on controlling him will probably get us through the entire video. It's not bad. It's only about 14 lines of code, but it's about understanding the logic. So I did want to call that out, that he technically already has the weapon. It's just the mesh renderer is disabled. That way it's not visible. Now, as far as the model itself, we've added so we already discussed the animator. We've added a capsule collider. It is not a trigger. Remember, everything is solid. Well, almost everything is solid. That way we can use gravity and everything stays on the surface of the girders, the beams. So it has a capsule collider. Now what I had to do is I did have to bump this up a little bit. By default, the center was 0.5. But here's the thing. Again, since this is solid, if this capsule collider, let's change that. If this capsule collider is too low below his feet, he's going to be raised over the ground, and you don't want that. So you got to get this just right so, the feet aren't clipping too much into the ground, nor is it raised too much over the ground. Visually, aesthetically, decide what you want to use. So is not a trigger, and we don't want him being levitated in the air. This is a script which we're going to review in a few minutes. And there's a rigid body. Again, we're using gravity, so we need to do that. And we are freezing the X and the Z rotation. Why? Well, just to give us more control, because we don't want him wobbling like that. And we don't want him wobbling like this. Some time ago, I had a game of Qbert that I was working on, and they kept wobbling, and that's when I discovered the ability to freeze rotation. We only want him to be able to rotate side to side. Okay, so I think I've called out everything about him. So now let's take a look at the script. Well, let's position him a little better. Okay, so on him is the script. And this isn't too bad. This is only about 14 lines of code, and you're going to see that's really 3 or 4 lines just repeated. So you're going to see certain concepts like checking for a key, applying a rotation, a Euler angle, and applying velocity. You're just going to see these really kind of reiterated a few different ways. I also do want to call out that if you're using a game controller, like for a console, that it would be simpler, because if you're using an analog stick returns a value from -1 to 0 to 1, and so you can just directly apply that to velocity, so it makes it a little bit easier. With a button press, you're checking to see if the button is pressed, and now you're coming up with a value to apply. So yes, if you use the game controller, this would probably be a little bit more concise, but again, it's only about 14 lines of code, which is pretty good. Okay, so private string mid jump equals no. This is just going to check to see if he is jumping or not. Now, some of you are probably going to say, why don't you use a Boolean? The reason why I don't use Booleans is because too many times I thought I only need 2 statuses, and then I needed a third, and I had to go back and recode. So you can't use a third status with a Boolean. So instead, I just use a string, and you don't have to uproot all that coding. You can just start checking for the third value. So out of habit, I just don't use Booleans. Okay, so we create the mid-jump string and then void update. And this isn't too bad because we've got this and then that at the end. So it's pretty concise. So we're checking 2 things. We're checking to see if the A key is pressed. So this is how you're going to walk left. And we're checking to make sure that mid-jump is set to no. Now it's just a string, but this will be changed to a yes when you're jumping. So I might go back and forth with how I express that, but the bottom line is that's what we're doing. We're checking to see if the A key has been pressed and are you jumping. If so if both of these are being done, get component transform Euler angle equals new vector 3, 0, -90, 0. So on the y-axis, it's being rotated at -90 degrees, so he's going to be facing left. Rinse and repeat. If input.getKey D and mid-jump equals N, get component transform Euler angles, new vector 3, 0, 90, 0. So it's 180 degrees in the opposite direction, be facing right. So like I said, rinse and repeat. You're seeing 2 statements that are almost identical. You're just checking for a different key, and you're just applying a different Euler angle. Otherwise, it's the same functionality. Now we're going to check to see if those keys are not being pressed because we want the character to stop. Now, technically, you could skip this step because if you wanted your character to kind of like slow down to a glide, you probably could get away with it. But in the original the original Donkey Kong, he stopped on a dime. There was no velocity. So keeping in line with that, we're going to have him stop immediately if a key is not being pressed. That velocity will be immediately set to 0. So this is how you check to see if something is not being pressed. You use the exclamation point. So just as this says input.getKey, this is exclamation input.getKey. So it looks a little bit weird the first time you see it, but that's how you check to see if something is not true as far as input. So it's kind of like if you've ever seen not equal, you do that, an exclamation point and then an equal sign. That is not equal. So if input.getKey A, so again, this up here, if it's not being pressed and get key D is not being pressed. So we check to see if this is pressed. We check to see this pressed. We're now checking to see if this and this are not pressed, and we are not jumping. That is, mid jump is not set to yes. So this is set to no. So you're not pressing the A key to go left. You're not pressing the D key to go right, and you're not jumping. Then in that case, stop. Get component, rigid body, velocity equals new vector 3, 0, 0, 0. Like I said, we're just stopping immediately. They're not going to glide to a halt. They actually glide pretty quickly since it's an incline, but we're going to use, we're just going to have them stop on a dime. Get component animator, play idle. So this is what you're going to see a few times. This is how I was saying about you overtly call out what animation you want to play. So if you have a climb animation and you're at the part where you're going to climb, it would be get component animator dot play climb, presuming that's what it's called. Or if there's a jump animation, it'd be play jump. So just keep in mind that's what you would do if you have those additional animations. Now, these ifs are standalone. If, but this one, after we say if, we say, well, else. So in other words, you're saying, okay, we checked for these, but now we want to check for something else. And we're saying if mid jump is equal to n. So you're like, wait a second, you already checked for that. Trust me, I fought with this for about an hour. You check a second time, because what are you doing now? Now, what you're doing is you're actually applying forward velocity. So if you notice, there's no repeat here for moving forward. You're pressing A, this only sets the rotation. You're pressing D, this is only setting the rotation. So this is the first place that you actually see move forward. So I try to make the code as concise as possible. Get component animator play walk. Again, if you're trying to play an animation, that's all it is. Get component animator play and then the name of the animation. So in other words, if A is not pressed and D is not pressed and mid jump is equal to no, then you play the animation move forward. So if you want a little bit more explanation, this is looking for any one of these. This is only looking for this one. So that's the difference. The difference is you're only checking for this one. So this only needs, oh, excuse me, this needs all of them, whereas this one you only care about one of them. I hope I explained that well. So yeah, so if mid jump is not equal to no, so excuse me, if mid jump is equal to no, my apologies. If mid jump is equal to no, then get component dot velocity transform forward times 4. This is just a speed modifier, so you can make this speed whatever you want. 4 looked right to me. So last one. Now this is a standalone statement, so again, it's not conditional. So this is branching off of that as an else. This is not. This is a standalone. So if input.get key down space, so if you're pressing the space key, get component, rigid body, velocity, and this one's a little bit, because you're combining two different things, you want to make sure that if your character is moving forward, they continue to move forward, but you also want them to jump. So this one's a little bit messier. So space is for jump. So if you've pressed space, get component, rigid body, velocity equals new vector 3. What this does, get component, rigid body, dot velocity, dot x. This says whatever the x velocity is, keep it, because again, it's a vector 3, so this is x, this is y, this is z. So rather than superimposing a new value, this is simply saying grab the current velocity and keep using it. That way, this isn't overwriting what you've done here. Okay. And add 6 velocity, so 6 units per second on the y-axis. So keep the x velocity, add y velocity, don't change z because again, we're not going towards or away from the screen, or the camera rather. And this is where mid jump gets set to yes. And that's really it for the main control. What this does is this just checks when you've come back down to Earth, so to speak. So private void on collision, enter collision collision. And we saw something very similar with the barrel. We did a similar coding. So this simply says if collision, so that refers to that. I kind of don't like the fact that it says collision and then collision. For new people, that might be confusing as to what you're talking about. But this, when you highlight it, you can see it matches to this one. So if collision.gameObject.name is equal to girder, that's these up here. So these are the beams, okay? So if the name of the other object that's being collided with is girder, then mid jump is equal to no. So here, when you hit the space bar, it changes to yes. You'll go up into the air. As we said, gravity will automatically bring you down because if you notice, there's nothing here saying how long do you jump? You jump into the air, gravity does the rest. And this simply says that once you've collided with a girder, then this is set back to no. And now you can move left and right again. There might be some gaps in this. I didn't try every possibility, but again, player control is an iterative process. I'm sure you've played games that have terrible player control, so it's adding the iterations to make it just right. Again, if you use a game controller, it would probably be a little bit more concise because rather than doing things like this and this, you could just have a single statement that applies the velocity based on the axis and a button pressed to jump. So it would be a little bit cleaner. At the end of the series, if you want to see an alternate control method, I'll do it. But for now, I think this is pretty decent. And again, it's only like 14 lines of code, so it's not that bad, and it's really just repeating ideas. A key is being pressed, you're changing the UR angle, you're applying velocity to the rigid body, and you're playing the corresponding animation. So I hope it makes sense. Pause the video at some point so you can see the whole thing. And we'll save that. I'm not sure what I changed. I think that's when I changed the exclamation point at the very beginning of my explanation. But if I did not mess anything up, that is all it's going to take to make this work. So you can see as the idle animation, that's why I mentioned that at the beginning to explain it does it on its own because that's how it's set up. If I press D, he walks, maybe a little bit slow. I let go of D, stops on a dime. Press A, he turn around, he walks, let go, stops on a dime, goes back to the idle animation. So now if we jump in place, like I said, we can make him jump. We can give him the velocity. He just doesn't have a separate jump animation. Don't know if I mentioned it earlier, but you can take models and upload them to Mixamo, and then you can add animations there. Maybe I'll do that at the end. Again, I'm really just concerned with getting you guys the coding and the functionality. And then there's the running jump or walking jump. There we go. The only thing I don't like is I don't think the jump is quite high enough for the barrels. The perspective is a little bit hard to tell because since the camera is basically mid here, you're kind of looking down, so it makes it a little bit harder to see exactly how high he's jumping. So you might have to tweak things a little bit, like for instance, maybe actually, yeah, we'll figure that out. I was going to speculate, but I don't want to go off on a tangent. So I think that's about it for this video. I just really wanted to handle the character control because that's vital. The only other thing that's really left is grabbing the hammer. And then we'll have the attack animation. And I do want to mention that. So he does have an attack animation, but it's a standing animation. So if he's standing and he's attacking, that's fine. But Mario in the original Donkey Kong could walk and attack. This doesn't have a separate walking attacking animation. So when he's walking, he will have the attack animation, but his legs won't be walking, he'll just be sliding. But again, that's something that you would have requested if you're going to, whether you do this yourself and make your own 3D models that are animated, or if you're paying someone, you're commissioning something, you would make sure that you have that kind of versatility, that they give you that walking attack as well as a standing attack. So I hope that you found this useful. Please consider leaving a like if you liked it. Leave a comment if there's certain functionality that you want to see. The first video did pretty good, at least for the standards of my channel. So here's the second one. I hope that you found this useful. And if this one does well as well, I will do at least one more where he climbs up the ladders, grabs the hammer, destroys barrels. I do have to add that too because we need a spawner. In the first one, I just had the barrel be here by default. You'd actually want a spawner where these keep spawning. And then also he would climb up here and then that would end the round. And then we'll reevaluate to see if people want to see the other, there's 4 screens, I believe, in total. So we'll see if people want to see those other ones as well. So again, hope you found this useful and please do enjoy the rest of your day.